This is section 2.7, pre-calculus, and we're going to be continuing with our graphing of rational functions. In this section, I'm going to take you through some steps in order for us to help get some specific points on our graphs. Here are the steps that you can follow. So steps for sketching the graphs of rational functions. First of all, your first step is going to be that you want to see if you have any holes at all. Any holes, and you can do that by factoring and simplifying and finding any of the values that should be excluded. I want to remind you that when you do factor and cancel, you do need to make sure for your hole that you find the y value that corresponds to it. Your second step will be to find any y-intercepts, and you can do the y-intercept by always letting your x equal 0. And when you do that, you want to make sure that it's for all x. All x values. To find your x-intercept, we do the same. We let our y equal 0. I want to just show you something here. If I've got a function where you let your y equal to 0, and maybe you have x squared minus 4 on top, and you have something on bottom, let's say x. Well, if you want this fraction to be 0, really all that you care about is setting the numerator equal to 0. So just by setting the numerator equal to 0 only, that'll allow you to find your x-intercept or intercepts if there's more. Your vertical asymptote is going to, stay the same as what we've been doing in the last couple of days, where you set your denominator equal to 0. Your horizontal asymptote, you will compare the degrees, such as this right here. You're going to compare 2 and to 1, and so that would indicate in this case there's not a horizontal asymptote. Finally, the slant asymptote here, slant asymptote would indicate because your numerator, the degree is 1 larger than the denominator, and so you'll use long division to find that linear equation. When you use long division, you will get a y equals mx plus b form. And you would be able to graph that on your own. And finally, you use t-charts like this, x and y, in order to find sufficient points in order to figure out the rest of your curves. All right, what we're going to do is go through this step-by-step procedure, and we're going to go ahead and find and graph our examples. Here's our first problem. Okay, so let's go through the steps. Is there any factoring that we can do here on top and to bottom? And you can see that there's no factoring, so we're going to rule out there's not any holes at all. I'm just going to go through all those steps. So there's none. Second would be to find my y-intercept. My y-intercept by setting your x's equal to 0. And if we do that, you can see here you're going to divide by 0, so that's undefined. So there are also no y-intercepts. X-intercepts. We're going to set our numerator equal to 0 to find the x-intercept. We would do x plus 1 is equal to 0. So x must equal negative 1. So my x-intercept is negative 1, 0. We're looking now towards our vertical asymptotes. And you're going to let your denominator equal to 0 here, so that would be x equals 0, which is also why we do not have any y-intercept. It all runs together there. Horizontal asymptotes. What we're going to do is compare the degree here. I've got a degree of 1 on top, 1 on bottom, so I'm going to use the ratio of their coefficients. So the horizontal asymptote is y equals 1. All right, if you have a horizontal asymptote, you do not have a slant asymptote. And now we're ready to graph by plotting some points x and y. I'm also going to put all the information in that I know. I know that I have a vertical asymptote here at x equals 0. I also know that I have an x-intercept at negative 1, 0. So here. I have a horizontal asymptote at y equals 1. I do not have a y-intercept. In order for me to find out more points, what I'm going to do is I'm going to go ahead and plot some points that are to the left of the x-axis, or the left of our x vertical asymptote. So let's go ahead and pick, I already know -1, let's try -2. So if you substitute -2 in here, we are going to get -1 over -2, which is 1/2. So plot it, -2, 1/2. And we also know that our graph's slowly going to approach the asymptote here and our vertical asymptote there. All right, to get the other side of my graph, I'm going to want to put in points such as 1 and 2. Let's go ahead and put 1 in. We get 1 plus 1 is 2 over 1. So which is 2? So plotting the point 1, 2, and putting the point 2 in. 2 plus 1 is 3 over 2, 1.5. So over 2 up 1.5. And we can go ahead and finish out our curve going towards our asymptotes. So that's the graph of that function. All right, let's look at another example. The first thing that you're going to want to do is write the expression in factored form. So I can go ahead and write my numerator as x minus 2 in parentheses, and the denominator does factor. It factors to x minus 4 and x plus 2. Even though we factored this, there's no indication that I can cancel from top to bottom. There are no holes. We do not have a hole in this graph. Just because we factor doesn't mean there's a hole. You would have to be able to simplify this. All right, I'm going to go ahead and look at then my y-intercept. My y-intercept, I'm actually going to go back to the original because you're just going to let x equal 0. So if you have x is equal to 0, our result would be -2 to -8, which is 1/4. Y-intercept 0, 1/4. And I do that by putting 0 in for, I can put 0 in for all x's, and you're only left with -2/8. All right, next would be my x-intercept. And my x-intercept is I'm going to set my numerator equal to 0 here. So if this is equal to 0, either one of those, you get 2, so 2, 0. I want to look at my vertical asymptotes. Vertical asymptotes, my denominator, what would make my denominator go to 0? And so that would be x equals 4. I'm getting this from the factored expression and also x equals -2. So both of those are found from here, these expressions. Okay, now ready to look for my horizontal asymptotes. My horizontal asymptotes are going to occur. You want to compare the degree here. You've got a degree of 1 compared to a degree of 2. So that would indicate y equals 0 as my horizontal, which means I do not have a slant asymptote. All right, let's graph all the parts that I know. I've got a horizontal asymptote at 0. I've got a vertical asymptote at 4. And also one at -2. All right, I also know that I've got a y-intercept at 0, 1/4. I'm going to go ahead and put these points in here. 0 and then 1/4. This is 1 here. I have an x-intercept at 2, 0. And that's all of the parts that I was able to find. Something to keep in mind. You can, when you build your table of values or when you plot your points, you can cross your horizontal asymptote, just not as you go to a value of x that's to infinity or -infinity. So only as your graph approaches the horizontal line on the left side and right side. It does not matter in the middle. All right, let's find one more point here in my graph. So let's go ahead and put in 3. If I put 3 in, I get 3 minus 2, which is 1. I have 1 on top, over negative 1 times 5. If I put 3 in, I get negative 1 times 5, so negative 1/5. I'm going to plot this point over 3 down a fifth. You can see here that if I even put in a negative 1, if I put negative 1 in, I get negative 3 on top, and on bottom I would have 5 times 1. I'd have, if I put in again negative 1, I'd have negative 5 times 1, so that's negative 3/5, which actually turns into positive 3/5. I'm looking at a graph in the middle section that slowly comes towards the origin, flattens out, and then back towards the asymptote. What I need to do is figure out what happens on the left side of negative 2 and the right side of 4 in this area. So let's go ahead and put a point in. Let's try negative 3. If we put negative 3 in, we get negative 5 over negative 7 times negative 1. Again, we'd have negative 7 times negative 1, which is 7. So negative 5/7. I'm going to plot that 1, 2, over negative 3 and down 5/7. We're in here. So I know that my region is going to go slowly approach the asymptote for the horizontal and vertical. We got one more section. Let's see what happens when x is 5. 5 minus 2 is 3. That's on top. And then we would have 5 minus 4, 1 times 7, so 7, 3/7. All right, and that slowly approaches the asymptote here. Now you can always build your table of values and plot more points, but that's what your graph will look like. All right, let's see what we got. Another example here, and it is x over x squared plus 1. There's no factoring, so I don't have any holes. Let's find my y-intercept. My y-intercept would be by letting x equals 0. And if that's the case, then I have 0 over 1, which is 0. So my y-intercept happens to be the origin. My x-intercept is by letting the numerator equal 0. So that would be 0. Another point, again, the origin. Setting your numerator equal to 0, x would be 0. Vertical asymptotes. Is there anything that would cause the denominator to go to 0? If you set x squared plus 1 equal to 0, this would be x squared equals negative 1. So you're going to get an imaginary. So you do not have any vertical asymptotes. So there's none. Horizontal asymptote. Horizontal asymptote, you're going to compare the degrees, and my degrees are 1 on top to 2 on bottom, and that's less than. So my horizontal asymptote is y equals 0. Let's go ahead and graph. We do not have a slant asymptote. I do know that I've got a horizontal asymptote at 0. I do not have a vertical asymptote. I have an intercept of the origin for both the x and y axis. So now what I need to do is build a table of values and find some other points. Let's go ahead and put in 1. If I put 1, I have 1 over 1 plus 1, so it's 1/2. If I put in 2, then I've got 2 over 5, which is 2/5. And let's put in 3 just for fun. We got 3 over 9 plus 1, so 3/10. As I'm getting smaller and smaller here. So you can see on this right side, I go up, but then I'm coming back down towards that asymptote. Let's look at the left side. If I put in negative 1, I get negative 1 over 2, so negative 1/2. You're going to see here that this is somewhat of a reflection about the origin. And so my graph on this side is going to do the same and then go and slowly approach the asymptote. All right, that is the graph of this function. We got one graph left. Sketch and graph by hand. We're going to go ahead and make sure we go through and factor this. You can take out an x squared, and you get x minus 2 left over Factor the difference of squares, x plus 2 times x minus 2. Well, this does indicate that I can cross out this x minus 2, and we just have x squared over x plus 2. So there's some things here that we can go ahead and identify. First of all, there is a whole. The whole would occur at 2, so it's the excluded value, 2. And if you put 2 into the function, the reduced function, if you put that in here, you're going to put 2 in, you get 4 over 4, which is 1. So there's the rest of that whole. All right, let's look at my y-intercept. Y-intercept is when x is equal to 0. And so you can see here we've got 0 over 2, which is 0. So that is going to give us the origin. X-intercept. X-intercept is simply by letting your numerator equal 0 here, the numerator, so that is also giving us the origin. If you let x squared right here equal 0. Horizontal asymptote. Well, let's do the vertical asymptote first. Vertical asymptote, you're looking at your denominator only. So we're looking at x plus 2 here. So that would be x equals negative 2. Horizontal asymptote, you're going to look at the degrees. The degree on top is 2. The degree on bottom is 1. You're comparing 2 to 1. It's bigger, so you have no horizontal asymptote, none. But you do have a slant. And this is how you find your slant asymptote. We're going to take x plus 2, and we're going to divide it into x squared, and you want to put your placeholders in here. It just looks like we're going to have to divide once or twice here. You can divide, you get x on top, and multiply down, x squared plus 2x. And when we subtract, when I subtract here, I get negative 2x, and I can bring down the 0. So the last division would be negative 2. This is my horizontal line that I use. So y equals x minus 2. You can ignore any remainder that you would get. All right, let's graph. Everything that I know, I've got a slant asymptote at x minus 2, which would give us this diagonal line. I also have a vertical asymptote at x equals negative 2. I've got a origin here. The origin is a point on my graph, and 2, 1 is a hole. Well, I can pretty much tell here in that first region that my graph comes down, crosses through the origin, and goes right back up through the hole. Now let's just see what happens to the left of x equals negative 2. Let's put in negative 3. If you put negative 3 in, I would recommend putting that into the simplified expression right here. So negative 3, you'd have 9 over negative 1. So negative 9. I'm going to plot left 3 down 9. So we're way down here. We know then our region is going to go ahead and look like this. So that's how you graph these rational expressions. This is your assignment for this last section here with rational and the graphing of rational expressions.